Hi guys! Today we're going to look at how 3D lighting works in Unity and how we can use the various lighting modes to improve the appearance of a game. We'll go through some of the different types of lights available in Unity. Then we'll look at how real-time, baked and mixed lighting works. We'll also explain how we can use light probes to improve the lighting of dynamic objects in our game. Okay, we'll start by creating a new 3D URP project in Unity Hub. Once the project is loaded, we'll create a basic scene to demonstrate how lighting works. We'll click the plus button on the hierarchy and select 3D Object, Plane. We'll make this a bit bigger by setting the scale to 10 on the X and Z axes. Then we'll create a material for this by clicking the plus button on the project panel and selecting Material. We'll set the base map to a green colour. We need to make sure that it's not 100% green though. We'll come back to why shortly, but for now we'll just make sure the colour has some red and blue components. We'll drag this material onto the plane to assign it. Next we'll add some walls. We'll click the plus button on the hierarchy and select 3D Object, Cube. We'll set the position to 2 on the y-axis. And we'll set the scale to 10 on the x-axis and 4 on the y-axis. Then we'll add another material. For this one we'll set the base map to a blue colour. Then we'll drag the material onto the wall. Next we'll create another wall. We'll right-click the blue wall in the hierarchy and select Duplicate. We'll change the position of this one to -10 on the x-axis. Then we'll create a new material for this wall. We'll set the base map to a yellow colour. Then we'll drag this onto the wall to assign it. Next, we'll duplicate the blue wall one more time. We'll change the position of this one to 10 on the x-axis. Then we'll create another material. And we'll set the base map of this one to a red colour. Then we'll drag the material onto the wall. The final thing we'll add is a capsule to represent a player in our scene. We'll set the position of this to 1 on the y-axis and -2.5 on the z-axis. Then we'll create another material. For this one, we'll leave the base map as white and drag it onto the capsule to assign it. Now we've got everything we need for our basic scene. We can see that the scene is already lit without us having to do anything. That's because the default scene in Unity starts with a directional light. Directional lights are used to represent light sources a long distance away, such as the sun or moon. The influence of a directional light on a scene is purely determined by its direction. The position has no effect. Let's select the directional light in the hierarchy. If we change the position, we can see that nothing changes. Let's try changing the rotation. Now we can see the light in the scene changing. The intensity of the light on a surface is determined by how close the direction of the light matches the direction of the surface. Let's point the light directly at the front of the walls. We can see that this surface is now bright, as it's getting the full intensity of the light. The top and other side of the wall are darker, as the light isn't pointing towards them. Let's put the light at more of an angle. Now the front is a bit darker, as the light is less direct. The top is brighter though, as it's now receiving more light. The colour of the light also has an effect. Let's try changing it in the inspector to see what happens. We can see that it tints the scene based on the colour we choose. At a high level, the final colour of the object in the scene is calculated by multiplying the original colour by the light colour, and then multiplying this by the intensity of the light, as determined by the direction of the light towards the surface. Let's set the colour back to white. If we look on the other side of the wall, we can see that there are also shadows cast by the light. We're not going to go into too much detail on how this works, but basically Unity renders the scene from the perspective of the light. It then uses this to work out which areas aren't visible to the light and should be in shadow. You may notice that the areas in shadow aren't completely black though. That's because of something called environment lighting. Let's turn off the directional light to get a better view of what this looks like. Unity is calculating this lighting from the skybox in the scene, and it ensures there's a small amount of light even in the shadows. We can change the intensity of this in the lighting settings. We'll go to the main menu and select Window, Rendering, Lighting. We'll drag this over and dock it on the right. We'll go to the Environment tab and change the intensity of the environment lighting to see the effect. If we set this to 0, we can see that the scene is now really dark. Let's turn back on the directional light to see what it looks like with no environment lighting. Where the light's hitting the scene, it looks pretty much the same as before. On the other side of the wall though, it looks really dark. It looks much better with the environment lighting, so we'll set the intensity back to 1. Before we look at some more advanced lighting techniques, we'll have a quick look at some of the other lights we can use. We'll click the plus button on the hierarchy and select Light, Point Light. This differs from directional light in that the position matters. Let's position this one on the dark side of the wall. We can see that it's lit the wall at this point. Light is emitted in all directions from the position, and we can change the intensity and the range. This could be used for things like an indoor light or a campfire. Let's disable this and look at another light. We'll click the plus button on the hierarchy and select Light, Spotlight. This light has a position and a direction. We'll point this at the dark side of the wall. If we increase the intensity, we can see it lights up a spot on the wall like a torch beam. We can also change the angle of the light and the range. This could be used for things like street lights and headlights on cars. Okay, next we're going to look at baked lighting. Let's start by disabling all the lights in the scene. The environment lighting we're looking at now is currently being calculated in real time. This looks okay, but it isn't a very accurate representation of how light actually works. In the real world, light bounces off objects onto surrounding objects. This is often referred to as indirect lighting or global illumination. So for example, light would bounce off this yellow wall, causing a small amount of yellow light to tint the floor. This is where baked lighting comes in. Baked lighting allows more complex lighting calculations to be done up front and stored in a texture to be used at runtime. We can bake the environment lighting by going to the Scene tab on the lighting settings. In here we can see various settings for how the lighting will be calculated. We'll be changing some of these values later on. To allow us to do this, we need to create a new Lighting Settings asset by clicking the New button. We'll leave everything as it is for now and click Generate Lighting. Looking at the scene, it seems like nothing has changed. That's because baked lighting only affects objects marked as static. We'll select all the scenery objects in the hierarchy. And we'll tick the static checkbox in the inspector. Then we'll go back to the lighting settings and generate the lighting again. This time it will take much longer, so we'll fast forward until it's done. Now, if we look closely, we can see some subtle changes. There's some yellow light that has bounced from the yellow wall onto the ground. We can also see a small amount of red around the red wall. And the capsule has a blue tint from the blue wall. To make the effect of baking more obvious, let's add some more light to the scene. To do this, we'll add some immersion to the red wall. We'll select the red material in the project panel. Then we'll go to the inspector and turn on the immersion. We'll set the immersion colour to red and set the intensity to 2. Now we have this glowing wall, but it isn't affecting the surrounding scenery. Let's click the button to generate the lighting again. Now we can see that there's more red on the ground and a red tint on the side of the capsule. Let's temporarily disable the red wall in the inspector. Now we can clearly see the red tint baked into the ground. That's why, when we created the green material, it was important to make sure the red component wasn't 0. Remember, the effect of a light is determined by multiplying the light colour with the object colour. In this case, the light bouncing off this wall is red, so it will only affect the red colour of the object. If the red component of the green material was 0, then it would be multiplying by 0 and have no effect. OK, next we'll look at how to bake the directional light. Let's enable the wall and the directional light in the hierarchy. If we look at the settings for the directional light, we can see that there's a mode setting. This is currently set to real time, which means all the calculations for this light are done at runtime every frame. By doing the calculations every frame, it allows the scene to adapt to changes. For example, if we move the capsule around, the lighting and shadows are updated to match. This mode doesn't contribute to the baked lighting though. To have it contribute, we'll change the mode of the light to baked. Let's generate the lighting again. Now we can see the effect of the light bounces. We can see more yellow on the ground here. Let's take a closer look at the capsule. We can see some green bouncing off the ground. And we can see some blue on the side from the wall. The lighting in the scene is now completely baked. We can even disable the directional light and the scene stays lit. This works really well for static scenery, but we can't use it for objects that we intend to move. Let's try moving the capsule to see what happens. The lighting no longer updates and the shadow is left behind. Let's untick the static checkbox for the capsule to tell Unity we intend it to move. Then we'll generate the lighting again. Now the capsule is no longer receiving any lighting from the directional light, and there's no shadow at all. That's because baked lighting only affects static objects. Let's look at another lighting mode that will improve this. We'll select the directional light in the hierarchy and set the mode to mixed. This combines elements of real-time and baked lighting. How it does this depends on the settings. Let's go to the lighting settings to look at the mixed lighting options. We have baked Indirect, Subtractive and Shadowmask. Let's try Subtractive first. Subtractive uses baked lighting for both direct and indirect lighting, but it provides real-time shadows for one directional light only. Before we try this out, let's add in another light that casts a shadow. We'll enable the point light we created earlier. We'll set the mode of this light to mixed as well. We'll also turn on the shadows. OK, let's generate the lighting. Now the capsule is lit again and we have a shadow from the directional light. We also still have the indirect lighting on the static scenery. If we move the capsule over to the point light though, we can see that the shadow is unaffected. And if we move the capsule into the shadow of the wall, we can see that it's still lit. Subtractive has the lowest performance cost of the mixed light options, but it doesn't create very realistic lighting. You would only really consider using this if you were targeting low-end hardware. Next, we'll look at the baked indirect mode. In this mode, mixed lights will act like real-time lights, providing real-time lighting and shadows. It then mixes this with baked indirect lighting. Let's generate the lighting in this mode. We still get the indirect lighting and the shadow from the directional light. If we move the capsule to the other side of the wall though, we now get lighting and shadows from the point light. And if we move away from the light, the capsule is now in shadow. This gives much more realistic lighting. One limitation with this mode is that the shadows are only visible up to a certain distance. If we zoom out, we can see that the shadows eventually disappear. This can be fixed by using the Shadowmask mode. Shadowmask does everything that baked indirect does, but it also mixes in baked shadows for faraway objects. Let's generate the lighting in this mode. If we zoom out, the shadows don't disappear. This mode is the most expensive, but works well if you're creating a game where distant objects are visible. That covers all the mixed lighting modes. In general, mixed lighting is going to give better lighting than real-time or baked, but there is a performance cost. It will always have more runtime calculations than fully baked lighting, and it will use more memory than fully real-time lighting. We now know how to get direct and indirect lighting on the static objects in the scene, but currently the moving objects are only getting direct light. Let's look at how to fix this. First of all, we'll change the camera so that it has a good view of the whole scene. We'll position the scene view until we can see everything. Then we'll click on the camera in the hierarchy and select Game Object, Align with View. Now let's switch to the game view. We'll move the capsule along in front of the wall. What we want to see is some of the colour from the walls appearing on the side of the capsule, especially from the glowing red wall. At the moment it just stays completely white. For indirect light to be added to moving objects, we need to use something called light probes. These probes are positioned at various points all over the scene. Then, when the lighting is baked, the probes store information about the light passing through them. At runtime, the indirect light for moving objects is then calculated from the nearest light probes. Let's have a look at how this works. We'll click the plus button in the hierarchy and select Light Probe Group. If we switch to the scene view, we can now see these 8 yellow spheres. Each of these is a light probe. We can click Edit Light Probe Positions in the inspector to add more, or to move existing ones. We'll quickly place some probes in front of the wall. These probes need to be above the ground. They also need to not all be at the same height. We can also duplicate selected probes to speed up the process. Generally, you would spread light probes over the whole scene. There is a performance cost though, so you want to minimize the number by having them condensed only in areas with complex lighting. Then you can have fewer in areas where the light doesn't change much. Okay, let's generate the lighting again. Now we can see some of the indirect light on the capsule. There's some green on the bottom and some blue on the side. If we select the capsule in the hierarchy, we can see which light probes are affecting it. Let's switch to the game view and move the capsule along the wall. We can see the indirect light on the capsule change depending on the wall it's next to. Now we have direct and indirect lighting for static and moving objects in our scene. There is still one final scenario we haven't covered though. Many games have lighting that changes at runtime. For example, you may want to have a day-night cycle in your game. Let's simulate this by turning down the intensity of the directional light. We can see that the indirect lighting is now too bright. Because it was baked when the light was bright, it doesn't change as the light intensity changes. For this reason, if you want your lights to change, baking is not really an option. Fortunately, Unity has another option that allows indirect lighting to be calculated in real time. Let's go back to the lighting settings. We'll tick this box to turn on Realtime Global Illumination. And we'll turn off the baked global illumination. The other thing we need to change is on the red material. We need to change the global illumination on the emission from baked to real time. Then we'll generate the lighting. If we move the capsule, we can still see the indirect lighting affecting it. But now, if we change the intensity of the directional light, we can see it adjusts to lighting changes. This method still requires light probes for dynamic objects, and it doesn't look quite as good as the baked lighting, but it's a good option if you need it. Okay, that covers everything for this video. Hope you found it useful. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. If you have any questions or feedback on this video, let us know in the comments. Thanks guys!